everybody. Welcome to another edition of Math Rock Stars, which you are the star. You're the star of the Math Rock Star universe. All right, let's get after it. All right, today we're going to talk about modeling the multiplication of mixed numbers and improper fractions. It's going to be a cool catwalk type of day, guys. So get ready to get your modeling on. All right. Just like vegetables, they're always modeling something. So what happens with vegetables when you throw them in the ocean? You get sea cucumbers. See? Oh my goodness. It's like it never ends how awesome these jokes are. It never ends. It never ceases to amaze me how amazing they are. All right, so like I said, we're going to model multiplying mixed numbers and improper fractions. If you haven't seen my modeling fractions video, definitely go see it because it will definitely help you understand this one. Because this one's a little bit more of a tough concept when you're thinking about what it looks like to model these guys. So we're going to do things in like an area model. It's just all kinds of fun. All right. So just as a quick reminder, do you remember using area models with fractions? So if you haven't seen that last video, this is where it's at. But it kind of looks a little bit like this, right? So we have 3/4 times 2/7. But when we look at 3/4 times 2/7, what we like to think about is turning that multiplication symbol into an of each. And when we do that, we're able to say it a little bit differently and maybe get a little bit better of a conceptual understanding. Because what we're saying is we're taking 3/4 of each of these 2/7. So something's going to be broken into sevenths, and we want 2 of them. And then we're going to take 3/4 of each of those 2/7. Let's look at what that looks like real quick in a review. Okay, so here's our model. We put our fractions on each side. And I wish I would have put the 3/4 on the top and the 2/7 on the side because 3/4 is bigger than 2/7. But anyway. All right, so we take the 2/7 and we kind of start with the second fraction when we're thinking about multiplying, when we're doing models. It just tends to make a little bit more sense. So we take this same size shape and we break it into sevens. 1, 2, 3, 4, 5, 6, 7. And then we shade in 2 of them, okay? So that's our 2/7. And then we take another rectangle the same size and we cut it into 3/4. So 1, 2, 3, 4. And then we shade in 3 of them. Okay, so remember this? Is this all ringing a bell? So then when we take let me erase all this beautiful artwork. Gosh, I don't even know why I'm a math teacher. I should be an art teacher. This is amazing. So then we take that first, that fraction that we dealt with, so the 2/7, we put that up there because that represents 2/7 of our rectangle. And remember, we want 3/4 of each of those 2/7. So all we're concerned about is these 2/7, each one of those, okay? And then when this 3/7 comes, or 3/4 comes over it, these guys are going to intersect these guys, and they're going to tell us what 3/4 of 2/7 is. Do you see that? How the 3/4 impacted each one of these. So how many do we have? So when we're trying to figure out the answer, again, let me erase my Picasso. How many squares does area model have in all? Well, if you understand multiplication area models with just numbers, we went 7 by 4, and that gives us 28. So there's 28 in all, okay? And then how many of them are shaded in by both? Well, here was our 3/4 right here. I'm sorry, that was, yeah. And so that was our 2/7, and all we wanted was 3/4 of them. So the only ones that should be shaded in are where they cross each other. And so how many shaded in? That's 1, 2, 3, 4, 5, 6. So we have 6 out of 28, and that would be our answer. Okay, we'd probably have to simplify it, but we don't need to do that right now. Okay, just for understanding how that works. Well, guess what? It works with improper fractions too, but it's a little bit trickier. So hang in there. Let's see what we got. All right, so what if we use the same idea to multiply improper fractions? What makes a fraction improper? It's not following the rules. It's like stepping on the cracks on the side. No, improper fraction means that there are more parts than there are in the whole. So in other words, if we had a pizza cut into fourths and we had 7 pieces of it, that's not part of a whole. That's a whole and a part of the next one. So that's what makes it improper. The numerator is bigger than the denominator. All right, so let's see what that looks like, okay? So remember, we are taking 7/4 of each of the 4/3. All right, hang in there. This is going to be a little tricky. So we take our whole, all right? So this square, this rectangle is meant to represent a whole, okay? And so remember, each one of these guys, if they're improper fractions, are more than a whole. Get out of here. What does that even mean? Well, that means if I'm going to show 4/3, I'm going to have two of these rectangles. Because if I break the rectangle into thirds, all right, I'm sorry, I'm doing the fourths first. If I break this side into fourths, I need 7 of them, and a whole will only have 1, 2, 3, 4, and I need 7 of them. So I had to do another rectangle to get more of them. So now I have plenty so that I could shade them in. Okay, and what does that mean? Well, that means I got to shade in 7 of those fourths. Oh, okay. I see where you're heading with this one, big goofy guy. Well, let's go to the other one. So now I got 4/3. And so that means I'm going to break my rectangle into columns and I need to break it into thirds. Okay, well, let's do that. And I need 4 of them. So that's why I need another part over here, another hole so that I can get all of my 3/3 3/3 shaded in. And then that gives us one more third on the other one. Okay, so we're not done yet because this is where it gets a little tricky. So based on that, let me go ahead and erase my ink. Based on that, I have to give myself, let me go back so you can see it. I also have to take that third and do it down here as well. So we've got the whole part figured out. So we basically right here, we've combined 7/3 and 4/4. But now when I got my 3/4 down here, because that's what was left over, I need to mix it with the other guys as well. So I need to take my 3/3 and multiply it with that. So when I do, watch, I put my 3/3 over top of that, that gives me more shading. And then I need to do the same thing with the sevenths over on this other guy. Okay, so I need to put my 7/7 right there. Now it's overlapped, and I got to put a fourth guy in because I'm trying to do at this point. Now I'm trying to do combine the two parts. So I'm combining the 1/3, and because that was 1/3 left over after 3/3, and I'm combining the three. I'm sorry, I'm combining the 3/4 because that was what was left over after we got rid of a whole. And look what happens. Then I combine those. And once you do all that jazz, once you do all that, it's the same procedure, almost the same procedure as what you were going to do with the other style of multiplying fractions. This is the only weird thing. So when you're figuring this out, how many squares does our whole have? So our whole is this guy. It's the one that's completely covered. We don't need to figure out an all. We just need to figure out how much does our fraction have in all. Well, in this case, it was 3 times 4, so it had 12 in all, right? So that's our denominator, just like before. And then what we figure out is, let me erase some of this. Then we figure out how many are shaded in by both colors. Well, when I do this, I don't like to just count them. I just go ahead and write on top of each one of these. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that one has 12 colored in. This one has, this one right here has a row of 4. So we have 4. This one here has 3, 6, 9. So it has 9. And this one here has 3. And then you're just going to add all those up. 12 plus 4 is 16. 16 plus 9 is 25. And 25 plus 3 is 28. So our numerator is 28 and our denominator is 12 because that's what our whole would be. When we cut fourths into thirds, we have 12 as our denominator. And then we figure out where they all cross each other. And that's it. Okay, it's a little tricky, but I think you'll figure it out. You guys remember when you were doing 2-digit by 2-digit multiplication? Because I'm going to show you another way to do this. And this kind of helps with doing it with mixed numbers. So we take this. We say, if you don't know how to do this, man, this will help you when you're trying to do some multiplying 2 digits by 2 digits. So when you take 25 times 32, you could do the standard, 25 times 32 and multiply that. But some kids don't like that method. And some teachers didn't teach you that method. They taught you this method. And I'm telling you, if you don't know this method, it's going to really help you with this fraction, multiplying mixed numbers. So what we would do is we would take this 32. It's our bigger number. So we'd put it across the top, right? And then we break it into two nice numbers. We break it by 30 and then by 2. So 30 and 2 still represents the same thing. And then we would take 25 and do the same thing, 20 and 5. And then we just turn it into an area model. Okay, and we're going to try to find how to solve that. So all you would do is take each one of these parts and you would multiply them together. So 20 times 30 equals 600. And then 20 times 2 equals 40. And then 30 times 5 equals 150. and 2 times 10. I'm sorry, 2 times 5 equals 10. And what you've done is you've done a lot of multiplication. You've done this little thing called partial products, because remember, products is the answer to a multiplication problem. And what we have done is figured out 4 parts to the answer. So you take all your partial products and you add them up. You put them in a line, you add them up, and what you get is 800. And that's the final answer. That's the answer to this problem. It's a lot easier because you're multiplying by numbers that are way easier to multiply. Well, you can do that same thing in mixed numbers. So we can take our rectangle and we can break up each of our mixed numbers. So this would be 4 wholes and a half. And this would be 2 wholes and 3/4 of a whole. Put your rectangles up and just multiply. 2 times 4. So we have 2 wholes times 4 wholes equals what? It equals 8. And then we take 2 times 1/2 and it equals 1. So if I have 2 halves, put a half and a half together, you get 1. Then I take 4 and I'm multiplying it times 3/4. And that gives us 3. All right, so 4 times 3/4. So if I, you know how to multiply fractions now. And then if I had 3/4 times 1/8, 3/4 times 1/8, 3 times 1 is 3. Oh wait, can we say, yeah, 3/4 times 1/2. I'm sorry. Come on, Tal. 3/4 times 1/2 equals 3 times 1 is 3, 4 times 2 is 8, and that's where that answer comes in. But those are partial products. So what do? Just like the other one, we put all of our products down here. We put our 8, our 3, and our 1. Those are all wholes, so we could just add those up, and we end up getting 12. 8 plus 3 is 11, plus 1 is 12, and then we bring the 3/8 down, and that's our answer. That's how you multiply mixed numbers. That's how you show it anyway. You can show it through area models, okay? So it's pretty. If you have improper fractions, you can do the way I showed you with all the shading and the coloring. And if you have mixed numbers, put it back into a standard area model just like you did with multiplication. And live the dream when you get there. It's going to be a rocking good time. Hey, what do you get when you borrow money from a cow? A buffalone. Buffalone, like a buffalo. Are you listening? Like a borrow money, so it's a loan, so it's a buffalone. The bigger question is, how did the cow get money? The loan, and then how did we communicate? It's a whole thing.